In this video, we're going to talk about how to get the derivative of an arctangent function. So the derivative of an arctangent function is equal to 1 over 1 plus x squared, or we can look at it this way, 1 over 1 plus x squared times the derivative of x squared. Okay. Perhaps an even better way of looking at it is the derivative of the arctangent of some argument, okay, it could be x, it could be y, it could be x squared, okay, is equal to 1 over 1 plus whatever this argument is squared times the derivative of that argument. So let's do that. Let's demonstrate that by doing an example here. So let's say we're given a function y is equal to the arctangent, okay, arctan e to the 2x, e to the 2x, and we're asked to find the derivative of that. So the derivative y prime, we can also write it as dy by dx, okay, exact same thing, y prime dy by dx is equal to 1 over 1 plus, okay, 1 plus whatever this box is, okay, whatever that is, squared. Now in this case it's e to the 2x, so 1 plus e to the 2x squared. And then we're going to multiply that by the derivative, okay, by the derivative of that argument of this. So the derivative of e to the 2x. And in this case it's just going to be e to the 2x times the derivative of 2x, which is just 2. So from here we can go ahead and simplify this expression to make it look a little bit neater. So we can write in our numerator 2e to the 2x divided by 1 plus e. Now as you can see here, this entire term is squared. So what we can do here is whenever you have a function that has an exponent and then you're supposed to take the power of that function, you can just multiply the two exponents. So 2 times 2 is 4x. And that is the answer to the derivative of this function here. Let's do one more example. So let's say you're given a function f at x is equal to the arctangent arctan 2 to the x squared. How would we evaluate this? Well, f prime at x, okay, that would be the derivative. Or we can also write it as df at x, f at x by dx. Okay. Another way of writing it, this is known as Leibniz notation, is equal to 1 over 1 plus, okay, this entire term here, so 2 to the x squared times the derivative of this entire block here. Okay, so the derivative of this from, now if you think back to the video on the derivative of a general exponential function, it's going to be 2 to the power of x, or 2 to the power of x squared ln 2 times the derivative of this here, which is just going to be 2x. Okay, so to simplify this even further, we get 2 to the power of x squared ln 2 Also, actually, one thing I should mention too is you can think of this 2 here as having a 1 above it here. So to make it look even neater, what we can do is we can simplify it by writing, by just adding these two exponents, so x squared plus 1. So it'll be 2 to the power of x squared plus 1 times ln 2 times x. Okay, and then we'll just, in our denominator, simplify that as well. So we can multiply these two exponents here. So x squared times 2 is just 2 to the power of 2x squared. And we can actually simplify this denominator even further, because 2 squared is equal to 4, so we can write it this way. So the numerator will stay the same. So 2 to the x squared plus 1 ln 2 times x divided by, scroll down a little bit here, divided by 1 plus 4 to the power of x squared. So that would be the final answer for the derivative of this function here. So there you have it. That is how you calculate the derivative of an arctangent function.